Okay, so this is example 8. It's a little bit more difficult in a way, and the first part involves something a little bit different. So let me just correct this to be a 3. It's more like a 2 there. So what we've got here is a top heavy. It's actually still black. Oh, well, there you go. The colour looks like it's blue there. Top heavy algebraic fraction. So that means that the largest power on the numerator is bigger or the same than the denominator. So we can't do partial fractions on this. So this form here, okay, can actually be done, and actually this whole question can be done in one step, really, using the kind of same partial fractions method for some questions, but not for all questions. I think what the easiest thing to do here is to treat this as what it is, which is a polynomial division question. So what I'm going to do is the same method that we looked at earlier in the year for polynomial division. So this one's a black, but it actually is blue, confusingly. And I'm going to use my grid method for polynomial division. So I'm going to put my times by sign there. I'm going to put my x cubed minus x. And I'm just going to leave a gap there, which I'm going to put 0x squared. For me, that just helps me see those gaps that might be there. Some people don't like it. And then I'm going to fill in. So x to the 4 is my biggest value there. So that means this is going to be an x. That's going to be 0, but it's going to be 0x cubed. Again, I like that, just keeping everything in line effectively on our diagonals and such like. That's going to be negative x squared, which as you can see is what we're actually looking to get here. I've no more x cubes are required. So filling that in actually means this whole row is going to be 0. Now if you look back at the answer, we have an x, which is what we've got here, but there isn't anything else with it. There's not a number term with it, so it makes sense that this actually is just going to be 0, and then all these are going to be 0. So 0x squared, 0x, doesn't really matter. And then that's the end of our grid. We can't go any lower than numbers. So I'm just going to kind of signal. Just going to kind of close that. But I do still need on my numerator, I've got the x to the 4, I've got the negative x squared, but I need a plus 2. So I'm going to put this plus 2 here, and this is our section for our remainders. So I'm going to put in bracket remainders. My left-handedness is getting in the way of you being able to see this. I normally just put R, but that's my plus 2. So my final, putting it in this form, is fairly simple actually for this question. My answer is just going to be x, I'll put it up here, plus 2 over x cubed minus x. Okay, so that's part A. Part B wants us to write it into partial fractions. Okay, now we've got two things here. Oh, a bit high. So we've got the x and the 2 over x cubed minus x. So this obviously can't be written. So this is where the partial fractions is going to be. Me just getting an email. So I'm going to ignore the x for now and just hope I don't forget about it at the end. So I'm going to write that 2 over. Now to do partial fractions I need to factorise that. So it looks like it's going to be a single bracket. So I'm going to take an x out. And then it's going to be x squared, that's another email, minus 1. Okay. Now, again, not something that can be written in partial fraction at this point. So I'm just going to change that and it's going to be 2 over x. And hopefully what you can see or get used to, because this is something that occurs a lot within A-level maths, is a difference of 2 squares. Okay, we saw it the other day in our trigonometry question where we had something with powers of 4 in, so it's a bit of a hidden difference of 2 squares. I get my words out. This one a little bit less hidden. X minus 1, x plus 1. Neat that up a little bit. So that is going to be what I'm going to do partial fractions on. Okay, 3 different denominators. So I'm going to have 2 over x, x minus 1. The order in which you write them makes absolutely no difference, so don't worry about that. Centralise that up a little bit. Because I've got 3 things, do my little 3 lines again, I'm going to have a over x, again the order is irrelevant, b over x minus 1, and c over x plus 1. I'm going to multiply both sides through by those 3 denominators on the left, which in these kind of cases is still the same as the ones on the right. Unless we've got a bracket squared, that will be the case. And then I'm going to rewrite the left, so it's just going to be 2. still that identity symbol technically. And then each of these should have the two factors which are not or wasn't originally the denominator. So the A had an x, it's now got the other two. The B has got an x and an x plus 1. And the C has got the x and x minus 1. And I'm just going to go through the same process now to sub in different values of x to find A, B and C. So to find A, I want to get rid of the bracket that is common, or the factor that's common in B and C. It's not a bracket, it's just an x in fact. So that's just, well, 0 I guess. So we're going to sub 0 in for that one. To find B, I'm going to turn over in a minute. To find B, we want to get the common factor in C and A, which looks like it's going to be x minus 1. So that should be x equals 1. I'll do the rest, I'll do the last one on the next page in a minute. Okay. So substituting in this 0 is going to leave me with 2. Now the idea of using 0 is it should get rid of the second two letters, B and C, so I'm not even going to bother with those because subbing 0 into here and here will get rid of those. So 0, so that's going to be minus 1 times 1, so just negative 1a, or negative a in fact. So therefore a is going to be negative 2. Subbing in 1, so not too difficult again. I'm not going to use my calculator at this point, although it's not a problem to use it and it's might be better in some ways. Right, so again, I'm expecting A and C to cancel out, so I'm not going to write those down. I'm just going to write down B. So B times by 1 times by 1 plus, so times by 2. So 1 times by 2 is 2, so 2B. So again, quite simple, B is going to be 1. I have to try and remember what's going on while turning this over. So my last one is to find C. I'm going to want X, I think it's negative 1. Let me double check. Yeah, so they've both got x plus 1 in the brackets. So I've got x minus 1, just reminding myself here, so x minus 1, x plus 1, left-handedness in the way again, x plus 1 and x minus 1. As you can see, I've added a bracket around x for no other reason than my hand did it as I was writing. Okay, look at my blue pen again. So a little bit more fiddly with the negative 1. So 2. Now put the number in, so it's only an equal. So negative 1. So negative 1 take away 1 is negative 2. Oh, that one and that one are going anyway, aren't they? Wasting my time. So it's negative 1, and then negative 1 take away 1, so negative 2. So negative 1 and negative 2 is positive 2. So you see it's going to be 1. Okay, I'm just going to write out at the end then, not forgetting the x I had right at the start, this x here that we didn't use. So my answer now is going to be x plus, no, I think the negative 1 was a, so I might write this in a slightly different way at the end. Negative 2, oh, put the page up. So I'm actually going to change that to a minus, so minus 2 over x, which was x minus 1 and then x plus 1, just to allow me to get that. B was positive 1, so plus 1 there, and then C is plus 1 as well by the looks of it. Okay, so I've not checked the answers, but that is hopefully what we should get for this example.